Well, welcome everyone. We're so glad you're here. And just if you want to hop in the chat, let me know if you hear everything. All right. Just want to make sure. But happy spring and welcome. My name is Jenny Olson. I'm one of the clinical science liaisons here. And we are in for a treat today with our mini keynotes with Brendan Vermeyer. And just, whenever you are, we're happy you're here. And today just promises to be a very enlightening hour. So first, a couple of housekeeping things as usual. We will be sending out slides and recording. I know a lot of you ask this. This is high in demand, and I'm sure that you'll ask this throughout the presentation, but those will be sent, we promise. Please drop any questions in the Q&A box. We will get to as many as possible. We have an extended time today after the hour, so we'll get to that Q&A. And without further ado, I get to welcome my friend and colleague, Brendan. Brendan is a mental and metabolic health researcher, educator, and practitioner with a background in fitness and nutrition. He proudly serves as clinical science liaison at Microbiome Labs, bringing us and the world so much passion and expertise in gut-brain axis and all things mental health. So I'm very grateful for what he brings to our Microbiome Labs family and all of you guys, but all of the work that he does to elevate our functional health space is truly inspiring, Brendan. So with that, I'll let you take the reins.
Well, thank you, my friend. I really appreciate that. It's good to have you here for moral support as we throw down some microbiome cardiometabolic magic here. So thank you all so much for being here. I don't take your viewership for granted. The fact that you're taking time out of your busy lives, your busy practices to tune into our Microbiome Labs mini keynotes really does mean a lot. Now, cardiometabolic is our focus today, and I certainly have a lot to say about this topic. And literally right before we hopped on live, I was told that we're not really limited to 60 minutes. I was like, oh, well, let me throw a slide or two in here, unhide a couple things, because I think we can go a little bit more in depth than we normally would be able to in a 60-minute webinar. So let me go ahead and get the slides going here and we'll dive in. But thanks for being here. Don't be shy. Throw questions, comments in the chat box. Obviously, with my ADHD, I'll try to stay focused on the presentation, but I can multitask with 50 browsers open in my brain. But let me know where you're tuning in from. I'd be really curious, and what you hope to get out of today's webinar so I can do my best to cater the educational experience to your learning preferences. So with that, obviously at Microbiome Labs, we are pioneers and leaders in the microbiome space, well respected throughout the industry. And I'm just really grateful to have the opportunity to be a small part of this really amazing organization and team, the innovation of what we're working on constantly behind the scenes. So I see a lot of friends and colleagues in the audience. I wish we were in like an open room so I could see all your lovely faces, but we'll cultivate some really good energy here nonetheless. So again, thank you so much for being here. Now, today we're diving into a really, really cool subject of looking at this microbiome-nitric oxide nexus and how this impacts cardiometabolic health, vascular function. So I think you guys are going to get some really interesting clinical pearls that you can immediately implement into your practice, literally like today, this afternoon, right away. Some of the mechanisms can get a little bit complex. I've got some cool graphics to make it palatable, but it's kind of like once you conceptually understand it, you can't unsee it, you can't unlearn it, and you'll forever be thinking about some of these mechanisms and how you can really pretty easily optimize some of these pathways and mechanisms with some targeted lifestyle support, nutraceutical support, probiotic support. So let's go ahead and dive in. Let me take a peek, see where you guys are tuning in from here. LA, San Diego, Dallas, Arizona, Idaho, Jacksonville, Michigan, all over the place. Man, I love it. I'm here in Kansas City and it's a beautiful spring day. I'm kind of itching to go get my Shinrin-yoku forest bathing after this. But for now, let's throw down and talk about nitric oxide and cardiometabolic health and how it relates to the microbiota. I find this particular subject, this microbiome nitric oxide nexus, it's not well known enough. And I've actually been doing a lot of work in this space the past couple of years. So I'm very excited to have the opportunity to share this information. So just some basic presentation objectives before we dive in. We're going to obviously take a look at gaining a familiarity with how the microbiota largely and arguably predominantly regulates nitric oxide homeostasis, redox balance, and really the bioavailability of this miracle molecule that is nitric oxide. So we'll really take a deep dive into understanding when is nitric oxide promotion a good thing, when is it not such a good thing, and how the microbiome is really directly influencing this nitric oxide activity and how this impacts our vasculature health, endothelial function, and overall cardiometabolic function. So certainly, as Jenny alluded to, I do have a background in fitness and nutrition, which either makes me horribly biased, or maybe I have a thing or two to share that might help you all in your practices. And of course, I'll say it now, certainly we want to bake in our nutraceutical and probiotic intervention strategies with those lifestyle interventions, proper nutrition habits, exercise habits, lifestyle habits that really pull the most weight. But we can certainly make the journey a little bit easier and more palatable by immediately introducing some of these supplemental supports so we can get the physiology a little bit more optimized to make some of those lifestyle hurdles a little bit easier. So we're going to explore this really cool relationship with looking at the microbiota and microbiome composition, but also the critical role of vitamin D3 and K2 specifically in influencing vascular health. So we're going to go deep into the mechanisms on what drives arterial calcification that can cause more arterial stiffness, right? So what we really want is nice, fluid, loose vasculature and blood vessels so we can have our blood flowing, we can deliver oxygen to the cells, create cellular energy. And so without optimal vitamin D3, K2, and nitric oxide signaling, especially throw in a little pro-inflammatory lipopolysaccharide and things start going haywire very quickly. So of course, I want to make sure I equip you guys with proper testing strategies, things to be looking out for clinically, and obviously filling your toolbox with some really helpful tools that we can use to kind of hack some of these pathways. So now, as far as why cardiometabolic health matters, shouldn't even really need to speak to it too much. Obviously, cardiovascular disease is the leading cause of death worldwide, all Americans, and especially too, I always like to highlight that cerebrovascular disease is also in the top 10 leading causes of death. Certainly not a coincidence. So cardiovascular, cerebrovascular, things like stroke and contributing to obviously hypoxia in the brain that might drive chronic neuroinflammation and neurodegeneration, which can contribute to this Alzheimer's also being in the top 10. So vascular health is really such a critical component, especially here in America. So a lot of work to be done in this department. And obviously at Microbiome Labs, we're doing everything we can to serve the American population and really the world as we expand into other territories. So let's dive in a little bit of a 101 on this miracle molecule that is nitric oxide. Now, it's interesting because my background with nutrition and fitness, I was working at GNC, the supplement retailer, when I was like 18. I was really into fitness, I like to joke that I have a PhD in bro science. That joke doesn't always land, but I think it's kind of funny. Now, certainly with that fitness background, nitric oxide has been embraced for many years, decades even, in the fitness world, more as an ergogenic performance enhancing aid. Nitric oxide is usually best known in relation to promoting blood flow through expanding the diameter of our blood vessels, a process known as vasodilation. Now, certainly there's a lot of other aspects that we might get into because we have the time to be able to do that. But nitric oxide actually won the Nobel Prize in Physiology in 1998, and it was proclaimed Molecule of the Year in 1992. So anything that wins a Nobel Prize in Physiology, the award was given to 3 scientists for their groundbreaking work in discovering nitric oxide as a pleiotropic or multifaceted signaling molecule within the cardiometabolic system. It's still to date considered one of the greatest advancements in cardiovascular medicine is this discovery of nitric oxide. Now, like I said, though, it's pleiotropic, meaning it can have a lot of different signaling effects depending on the context, the milieu, the microenvironment, what tissues and cells are manufacturing the nitric oxide, at what quantities, for how long, and why. So sometimes nitric oxide gets a little bit demonized because it can be nuanced. Sometimes it's overdone and it can actually drive oxidative stress and inflammation. Other times it's very healing and health promoting. So it largely depends on the physiological context of what's going on. So I'll give you guys a little bit of an introduction there. But in the, sports nutrition, athletic performance world, nitric oxide supplementation, usually in the form of like L-arginine or L-citrulline, the amino acids that we need to make nitric oxide, are typically used, pre-workout powders are a great example. It's usually, caffeine and stimulants and some kind of nitric oxide component, maybe some creatine, maybe some beta alanine. So this is kind of like bro science 101, but here we are like 20 years later in the clinical world, the medical world, the functional medicine community is now looking at, well, actually, there's a lot of value in some of this, kind of classic bro science, fitness and sports nutrition principles, right? And this is where I love sort of this journey I've been on of going from, all right, how do I help clients optimize their metabolic health and metabolic performance with largely nutrition, lifestyle, psychology, and then now largely operating in the functional medicine world. So there's certainly a role for how do we effectively clinically implement these types of strategies to optimize the cardiometabolic health in our client and patient population. So as we get older, our nitric oxide levels do gradually decline. This is technically a gas. Nitric oxide is a diatomic molecule. It's one nitrogen, one oxygen, covalent bonds, neutral charge. It doesn't have a charge. And so it can act as a pro-oxidant and contribute to more oxidative stress, or it can act as an antioxidant and actually scavenge reactive oxygen species and radicals. So it really depends, again, on the context. Now, it's a gas with a half-life of about 2 milliseconds in the blood. So as soon as it's made in the body, it's going to very quickly become oxidized. And we'll describe that a little bit more. But the key component here is understanding nitric oxide is a gas. Let's also make sure we don't confuse it with nitrous oxide. That's laughing gas, or N2O. That second nitrogen makes a very, very big difference. And a lot of times people get confused on nitric oxide versus nitrous oxide. And believe me, there's other nitrogen species as well to be aware of. But these diagrams do a good job illustrating how, as we age, when we're undergoing what we call immunosenescence, or the aging of our immune system, which concomitantly corresponds with inflammaging, or essentially inflammation and oxidative stress creeping up on us as our cells, as our bodies are starting to age. This is just part of the aging process, right? The best thing we can do to optimize our longevity, though, is to try to keep inflammation and oxidative stress at bay for as long as possible. That's the secret to longevity right there. So as we do age, we actually lose our endogenous ability to effectively produce nitric oxide gas. This is a gas that it's being made basically in most tissues of the body all the time, at a microscopic level that it's hard for the human brain to really comprehend. So it's a gas that it's basically going to convey a signal within its localized tissues or nearby. Because it's a gas, it can very easily diffuse rapidly throughout the body. So it depends on where it's made. It can be made in the brain and the central nervous system, where it's more acting as a retrograde neurotransmitter that regulates the other neurotransmitters like serotonin, dopamine, and glutamate, but it's largely made within the endothelium, which is what we're looking at here, our vasculature, our arteries that are pumping blood throughout the body, right? And so obviously, if we have very narrow vasoconstricted blood vessels, blood isn't flowing properly. And as basic or even redundant as it might seem, blood flow is really kind of the foundation of all of human health. If we can't effectively drive blood through the body, through the fine capillaries, oxygenate the tissues, we're never going to be able to produce the cellular energy needed for biology to take place. So by the time we hit about 40 years old, it's estimated that we're at about 50% of our ability to produce nitric oxide. Meanwhile, especially if we have vitamin D insufficiencies, and especially vitamin K2 insufficiencies, not only do we have more vasoconstriction, but then also we get this arterial calcification as calcium is inappropriately deposited within the smooth muscle of the vasculature. So this is where we start getting that increased risk of atherosclerosis, and of course, concomitantly, an increased risk of cardiovascular disease. Whew, take a breath. So this was actually the slide that I was adjusting when I found out that we're not restricted to a tight 60 minutes. Now, certainly for the sake of today's presentation, I will say that nitric oxide, it is a rabbit hole that you can go pretty deep down. We're not going to go all the way to the bottom of that hole. I think we can have just a more basic conceptual understanding here. So let's start with this more simplistic diagram. And then if we want to take it a little bit deeper, we might. This is really critical to understand, though, because classically, when people think of nitric oxide, they're more thinking of the endogenous enzyme-driven nitric oxide synthase pathway, or the NOS pathway. So this is basically our human epigenetic pathway to manufacture this miracle molecule gas that is nitric oxide. And we use L-arginine as the source of nitrogen. We can also recycle citrulline to make more arginine in the body, but we use the arginine and essentially pump it through the nitric oxide synthase enzyme, or NOS. Now, there are different isoforms of NOS that I'll delineate further as we go, but we'll take that arginine to manufacture that nitric oxide so we can have that signaling effect. And largely in the context of cardiometabolic, we're talking within the endothelium, which is those cells that line our blood vessels. So we're talking about our vasculature in order to create that gas that stimulates what's known as cyclic GMP. And this causes smooth muscle relaxation to expand the diameter of our blood vessels. That's vasodilation. So this is why it's largely used as like a performance enhancing athletic supplement. If you're going to go run a marathon, it helps to have more vasodilation. Or if you're going to go lift weights and try to get a good strength training session. This is also why nitric oxide is classically used for erectile dysfunction, both for men and women. So looking at the PDE5 inhibitors or phosphodiesterase type 5 inhibitors, these are drugs that essentially work on the backside of the pathway to promote blood flow to the sexual organs. Now, we're focused more on heart health today, though. Now, like I said, this is redox biochemistry. We won't go super in depth, but nitric oxide is going to quickly, literally within about 3 milliseconds, become oxidized into nitrite, which is NO2 minus, and then further oxidized into nitrate, or NO3 minus. Don't worry, I'm not going to quiz you guys. You don't have to memorize any of this. This is just basic redox biochemistry and understanding oxidation reduction reactions, right? So previously, this was really thought to be the only mechanism that we make this miracle molecule within the human body. But in the past 2 decades, research and a growing body of evidence has illuminated that there's this alternative pathway known as the nitrate pathway. And this is where the microbiota comes into play. Now, I will candidly say, based on the research I've read and the work that I've done in this space, I would argue, I think this is a more ancient primordial pathway that I think you could argue this may very well be our predominant method for maintaining nitric oxide homeostasis in the body. And it is not exclusively, but heavily influenced and regulated by the microbiota, both in the oral cavity, the gut, all over the place. And so it is that nitric oxide that's going to exert those biological effects, whether it's the vasodilation of our vasculature so we can have blood flowing, but also when we think about the subject of lymphatic drainage, which has become a really hot topic in the functional medicine world, guess what? Your lymphatic vessels are also lined with endothelial cells, and they too express that endothelial nitric oxide synthase. So my point, nitric oxide doesn't just promote blood flow, it also promotes lymphatic drainage. And I don't think that gets nearly enough attention. So this is my more robust diagram that's a little bit more advanced than that last one. And so when we look at some of the biological effects of nitric oxide, again, it's the blood flow, it's regulating neurotransmission activity, but especially immune defense. And I want to highlight this because then when we get into the subject of metabolic endotoxemia, which is one of our core principles here at Microbiome Labs, this metabolic endotoxemia can very much disrupt our immune response. Now, where people get confused with nitric oxide and thinking that nitric oxide is a bad thing is when we have upregulated inducible nitric oxide synthase activity, which is a part of the inflammatory response. It is a part of the immunological response when our immune cells are activated by some sort of microbial pathogen or toxin such as lipopolysaccharide. So this is where it is helpful to understand with nitric oxide synthase, the enzyme that takes arginine to make nitric oxide gas. There's the three isoforms: neuronal nitric oxide synthase, which is, as the name suggests, largely expressed by our neurons. Then we have the inducible nitric oxide synthase. This is largely expressed by immune cells, particularly the macrophage in our tissues in the periphery, as well as microglial cells in the central nervous system. And what I really, really want to highlight here before we get into the endotoxemia component is understanding that when people are painting nitric oxide in a bad light, what they're doing is taking the inflammatory immune response out of context and then blaming it on nitric oxide and throwing nitric oxide under the bus. Because when our immune cells, particularly macrophages, are activated by something like lipopolysaccharide or other pathogen-associated molecular patterns, they're going to be activated and change their morphology to their M1 pro-inflammatory phenotype. So basically our immune cells are getting into their, fight or flight. We have to fight off a foreign invader infection type situation. And so what happens is the inducible nitric oxide synthase enzyme expressed by these immune cells, it's able to create thousands of times the magnitude of nitric oxide gas. Why does it do that? It uses the nitric oxide as an antimicrobial molecule to fight off the foreign invader. And this is quite literally the mechanism of septic shock. When somebody becomes septic, and they have too much bacteria and bacterial endotoxins and exotoxins that are flooding into their body systemically, such as through a leaky and dysbiotic gut, this overwhelms our immune system, and our immune cells are cranking out so much nitric oxide to try to fight off the infection that this is what drives low blood pressure and causes septic shock. So it's essentially a part of the immune defense that has gone haywire and has become overwhelmed in more severe septic conditions, right? Now, with cardiometabolic, we're largely going to be looking at how do we optimize the expression and activity of endothelial nitric oxide synthase that's making the nitric oxide to promote blood flow and heart health and cardiometabolic function, while basically mitigating the exaggerated nitric oxide response of the immune cells using the iNOS. And this is where we can actually circumvent a lot of the issues with this enzyme-driven pathway, because there are a lot of things that can disrupt our natural endogenous production. If we're lacking cofactors, whether it's oxygen or biopterin, NADPH, magnesium, so on and so forth, but there's also a lot of nitric oxide synthase single nucleotide polymorphisms, or SNPs, that might predispose individuals to lesser or greater nitric oxide activity. This can very much have clinical implications. So looking at the nitrate pathway, this is where we're able to consume dietary nitrate. This is the key term to be familiar with. Dietary nitrate comes from, guess what? Primarily dark green leafy things, which just so happen to also be our primary dietary source of vitamin K1. However, without adequate levels of specific microbes within the oral cavity and the gut, we can't really effectively convert K1 to K2, and we can't really effectively convert nitrate into nitric oxide because we're relying on some of the microbial enzymes to really do this biochemistry for us. So this is where it brings us to the conversation on the garden of life, that is the microbiota. And of course, every part of the body has its own unique microbiota, but in this context, we're focusing on the oral microbiota and the gut microbiota in particular. So that's a little bit of a crash course on nitric oxide, and I think about as deep as we need to go there. So now, as we move this conversation forward here, when we think of dietary sources of nitrate, things like bok choy, spinach, kale, arugula, like I said, also great sources of vitamin K1, which is more so involved in the clotting and coagulation aspect, whereas K2 is really what we're going to be focusing on today, that regulates the magic of making sure we move all the calcium out of our vasculature and into our bones where we really want it. So when we consume nitrate-rich foods such as beets, which beets are particularly robust and dense in dietary nitrate, or that NO3 minus molecule, which is more so like the circulating storage form of nitric oxide, if you will. So nitric oxide, like I said, only has half-life of about 2 milliseconds in the blood, whereas nitrite, NO2 minus, the oxidized intermediate form, has a longer half-life, about an hour, maybe a few hours. But nitrate, or NO3 minus, is the most stable molecule with the longest half-life of hours, even up to days, depending on the individual and how much nitric oxide their body is sort of using and consuming. But when we consume those dark green leafy vegetables or the beets or beet juice or supplemental dietary nitrate as potassium nitrate, that can be a great way to go, especially if you're worried about high oxalate foods, because unfortunately, a lot of our foods that are high in folate and K1 and nitrate are also very high in oxalates, and some people have issues with that. But as we consume that nitrate, a lot of that nitrate will get absorbed through the intestines and then recirculated throughout the body. We are going to excrete about 60% of it through the urine, but the rest of it will actually get recirculated to the salivary gland in our mouth. And so then what happens is we actually have about 10 times the concentration of nitrate in the salivary gland compared to systemic circulation. And then what happens is our saliva, assuming that we're consuming adequate levels of nitrate from our diet or supplements, but if we're consuming enough nitrate, we should have a high concentration of that nitrate in the saliva. And then when you start salivating in response to anticipating a meal, that nitrate is actually going to interact with key microbial species within the oral microbiota in the oral cavity and reduce the nitrate into nitrite. And so this is where we're relying on the microbes to take that nitrate and convert it into nitrite, which is then just one redox reaction away from being nitric oxide. So as we then swallow that nitrate and nitrite rich saliva down into our stomach, the acidic stomach environment helps to further reduce nitrate and nitrite into nitric oxide. So you kind of have to just have a basic understanding of redox biochemistry to appreciate the flux that's going on here. Nitric oxide to nitrite to nitrate, nitrate to nitrite to nitric oxide. And this is going on in a lot of different tissues of the body very quickly, depending on the biochemical microenvironment and what our body is really needing for signaling effects. So then we're able to produce nitric oxide in the oral cavity, the stomach, and also some of those key microbial species in the oral cavity are also should be living in the gastrointestinal microbiota. So then there's a lot more nitrate to nitric oxide flux going on literally within our intestinal microbiota. So this is a really, really intricate process, but the take home here is let's make sure we're eating enough dark green leafy things or making sure we're consuming adequate nitrate and folate and vitamin K1 and all of these other critical nutrients that are facilitating this robust biochemistry that largely influences cardiometabolic health. So this is a great diagram that I made to illustrate this with how those oral microbiota species like Haemophilus and Neisseria, Rothia, so on and so forth, these are some of our key nitrate reducing species. Now, some of them are more so nitrate reducers, other are more nitrite reducers, and then we should have a number of these in the gastrointestinal microbiota. And so we can use the Biome-FX from Microbiome Labs to get a very in-depth look at what species are present within our stool samples. So for example, we look at Prevotella within the Biome-FX, and this can have correlations with the oral microbiota and influence the ability to reduce nitrate to make this miracle molecule that is nitric oxide. It certainly opens up a whole conversation that we could have about oral hygiene, not the focus of today's presentation, but I will offer this clinical pearl because there's a number of research papers that have been published doing experiments such as using chlorhexidine-based mouthwash, such as Listerine that everybody uses or buys from the store. But that chlorhexidine-based mouthwash is very antiseptic. It kills a lot of our oral microbes. So they've actually done research that shows even just using a little bit of Listerine and chlorhexidine-based mouthwash can very quickly cause increases in blood pressure. Why? because we're killing off the microbes that help to make nitric oxide that can lower blood pressure by expanding the diameter of our vasculature. So when we think about how many millions of Americans are on blood pressure medications and using Listerine every day and proton pump inhibitors that are decreasing the acidity of their stomach acid, no wonder so many individuals in America are having hypertension and GI issues and this sort of metabolic illness sequelae that we're all dealing with in our practices every single day. So I think this is just such cool information that we can use to intervene more intelligently with our patient population. So now, of course, as we take a closer look at gut dysbiosis, intestinal permeability, and metabolic endotoxemia, this is going to be really exciting, I think. I'm jazzed. Let me check the chat box to make sure you guys are excited too. We have a great audience here today, over 90 people live, over 500 registered. Awesome. Yes, the slides will be shared with you. So
Brandon, someone was just as you were on the topic of oral hygiene, they were just wondering if you could talk a little bit about mouth breathing, if that comes up, if you know anything about that, and if brushing with baking soda is okay.
oh, yeah, thanks, Jenny. Good question. So let me go back to that slide real quick since we're on that subject. I'm not sure about baking soda. I'd have to look into that a little bit. I doubt that it would harm the oral microbes the same way that fluoride toothpaste or chlorhexidine-based mouthwash. So certainly the only thing with mouth breathing, a lot of people will do the mouth tape overnight because yes, actually we have more nitric oxide synthase enzymes within our nasal passage. So nasal breathing is more effective at promoting nitric oxide throughout the body as opposed to mouth breathing. So if you did like the mouth taping overnight and do more nasal breathing exercises, that can help. But with the mouth breathing, maybe we might dry out our mouth a little bit, and that could have implications for the oral microbiota composition. So great question.
Nice segue. Thank you, Brendan.
Yeah, thank you, Jenny. All right, so then back to the gut dysbiosis and hyperpermeability. Any of you that have been hanging out with us at Microbiome Labs for long enough, you've probably seen this diagram. It's pretty famous at this point in time throughout the industry. So certainly when we think about some of the features of a healthy eubiotic microbiota in gut, we want lots of diversity in our intestinal microbiota. This is largely within the colon. One of the things that with all the microbiome research that's been done all over the world, more diversity equals better health outcomes. That is one of the few things that's really pretty solid. Certainly there's a lot of mysteries with the garden of life still that, we're working every day to unpack, but we want a high alpha diversity, which is the total number of species present in the gut. And we also want high beta diversity, which is species richness, the quality of the participants in your unique ecosystem, right? So we have to make sure that we have adequate levels of our keystone strains, things like Faecalibacterium prausnitzii that produces a lot of butyrate, or Bifidobacterium longum that can modulate the gut-brain axis. We need plenty of mucin. We have this mucin 1 and 2 layer that kind of acts as that chemical defense barrier to protect our enterocytes and our intestinal lining from some of these naughty opportunistic pathogens or antigens, toxicants, heavy metals, all the things that we're dumping into our body through our diet, lifestyle, and ingestion here. And so obviously, if we have some type of imbalance in our flora, largely due to, ultra processed food diet, sedentary lifestyle, increased stress levels, poor hydration, toxic burden, all of the things, we can get low diversity and an increase in opportunistic pathogens. So this is where I love the BiomeFX in the way that we report the findings of the ecosystem with diversity metrics, looking at the pathogen load of how many of these pathogens are starting to opportunistically proliferate out of control. And this can lead to this intestinal hyperpermeability. Our tight junctions get loose and damaged. We get inflammation to the tissues of the colonocytes and enterocytes here. So now this is where this is really setting the stage for more translocation or leakage of a lot of these naughty pathogen-associated molecular patterns. That lipopolysaccharide being kind of the key one, which it's really the best studied pathogen-associated molecular pattern, but it's not the only one. but we're going to focus a lot on this lipopolysaccharide component here. So taking a little bit of a closer look. So we're really looking at gram-negative bacteria in particular. Those of you using the Biome-FX, we're really talking about the proteobacteria phyla. This is the phyla or category of bacteria that compose a lot of these more gram-negative, some of the potentially naughty microbes that express this lipopolysaccharide as part of its cellular membrane. Now, the lipid A moiety, this is the component of the lipopolysaccharide endotoxin that really ticks off our immune cells and triggers an inflammatory response. So then essentially what's going on, if we zoom in a little bit here and have this blown up schematic, is when we have increased intestinal permeability and endotoxin burden or endotoxemia load, if you will, sort of like a subclinical sepsis. You know, if we think about sepsis and septic shock as like 10 on the Richter scale, the severity scale, versus 0 would be a nice, really healthy, high diversity, eubiotic, strong, tight junction intestinal lining here. So the question that we have to be asking is all of our individual clients and patients, where are they on that endotoxemia spectrum right here, right now? Are they pushing a 7 and they have, you know, more inflammation in their body and their brain driving symptom clusters across multi-systems? Or are they a little bit more moderate? They might not even know that they have intestinal permeability or dysbiosis until we do a functional microbiome analysis with the Biome-FX. So tying this back to the nitric oxide component, I know that we're going relatively in depth on some of this stuff, but this is where, if we look at this little blue guy down here, this is a macrophage, or symbolic of a tissue-resident macrophage. And I actually, with my very amateur graphic design skills, I put iNOS right here. So if you look at that closely, it says iNOS, and that is supposed to represent inducible nitric oxide synthase. Because like I said, we have these unique isoforms of the nitric oxide synthase enzyme. And so when we have those naughty little lipopolysaccharide endotoxins leaking through a hyperpermeable intestinal lining, it will then bind onto specific toll-like receptors, specifically TLR4, if you're nerdy enough to care. But the CD14 TLR4 complex, this is what the lipopolysaccharide activates, that then will stimulate the production of various pro-inflammatory cytokines like interleukin-6, TNF-alpha, interleukin-beta, that's going to drive a systemic inflammatory response. But like I said, it's also going to upregulate the expression of inducible nitric oxide synthase. Now these macrophages are churning out thousands of times the magnitude of nitric oxide, not within our vasculature to promote blood flow, but within our tissues where it's driving inflammation and oxidative stress. And this is where nitric oxide gets thrown under the bus as being a bad thing. That's completely inaccurate and physiologically incorrect. It's understanding that the nitric oxide production is part of the inflammatory response that's really being driven by a dysbiotic and leaky gut. So I hope that blows your mind. I think it's really, really cool. So then as we're going to go here through the rest of the presentations, I want to offer you guys some really great strategies that we can very quickly modulate and correct this, right? So this is where I would really advocate, as our whole industry likes to say, test, don't guess. Let's use the Biome-FX. Let's use our functional microbiome analysis so we can really gain a deeper insight into the composition of your patient and client's ecosystem living in their intestines. So I included a screenshot here to, this is one of my clients' Biome-FX test results from, actually, I think it was a while back, maybe a few years ago. And if I know it's a little bit small, so you can zoom in a little bit if you need to, but this is looking at the proteobacteria phyla. So this is the phyla that I mentioned can be a little bit more naughty, a little bit more gram-negative bacteria expressing those lipopolysaccharide, in contrast to the actinobacteria that is more anti-inflammatory bacteria, such as Bifidobacterium species. And as you can see with this particular test result, she had a very, very high ratio of the more pro-inflammatory proteobacteria in relation to the anti-inflammatory actinobacteria. This is actually one of the highest ratios I've seen, and this was my client at 57. And I kind of wish I had included the post results because we got that ratio from like 57 to 2. Now, it took like 3 years of microbiome landscaping and using spore biotics and immunoglobulins and total gut restoration for literally years, but we were able to increase our alpha diversity 54 more species upon retesting. We were able to improve the phyla ratios that are kind of like the pillars of the rainforest, if you will. So I love the biome effects. I am one of the consultants. So of course, if any of you choose to incorporate this amazing clinical tool into your practice, you can hang out with Jenny, you can hang out with me or our other amazing clinical science liaisons, and we can help teach you how to incorporate this tool into your practice. Okay, that was a lot of information. So now let's really look at how do we bridge the gap here? How do we take this cool science and mechanistic understanding and apply it to optimize cardiometabolic resilience, right? This is what we're trying to avoid. With a life expectancy of about 77 and declining in America, with cardiovascular, cerebrovascular, dementia, all of these major chronic diseases that are plaguing our nation, this is the recipe right here. How do we optimize and prevent this arterial calcification, this hypertension, the atherosclerotic lesions, so on and so forth. So we're going to be taking a look at, of course, I want to emphasize the importance of lifestyle one more time. I'm not here today to teach you how to build a proper exercise regimen or nutritional habits or optimal psychology, so on and so forth. But I can't emphasize enough that that is really the foundation that we have to be building off. Now, as functional providers, though, of course, we can use our amazing supplemental strategies to move the needle a little bit quicker, because I think, as we can all appreciate as clinicians and practitioners, if we don't quickly start moving the needle and getting our clients and patients feeling better, having more energy, less aches and pains, more cognitive clarity, it's going to be really hard to make those neurolimbic rewirings to change their behavior in a way that's going to be sustainable, right? So I love using some intelligently designed protocols to very quickly augment and support their physiology to move the needle faster and boost compliance and rapport for the long run, right? So with this, some of the key things that we're going to be trying to do is how do we optimize their microbiome health and their overall eubiotic status and microbial diversity? How do we decrease that endotoxin burden to decrease the endotoxemia component that's driving this systemic and even neuroinflammatory response from the lipopolysaccharide and other PAMPs from a dysbiotic microbiome? And how can we use some of our microbiome labs products, such as our Mega Marine with the omega-3s and pro-resolving mediators, our D3K2 formulation, immunoglobulin, so on and so forth. So I'm going to give you guys kind of the quick and dirty of how I approach this and how I've gotten great results with a lot of my clients. So taking a deeper look at this arterial calcification, though, because this is such a major component that's going on as part of this basically vasculature dysfunction sequelae. It's part of this disease process that's driving the leading cause of death in Americans. So I think we all can appreciate vitamin D3. It's really an amazing steroid hormone vitamin thing that we all know about. And I think there's a lot of mysteries around D3 that are very much misunderstood. So I do advise it's great to be testing 25-hydroxy D3 in your patient's blood in conjunction with 125-dihydroxy D3, also known as calcitriol. That's the bioactive, bioavailable form, and most clinicians are really only looking at 25-hydroxy D3, which is the prohormone. Part of the problem with measuring D3 in the blood, which is why I'm giving you guys this clinical pearl, is that 25-hydroxy-D3, the prohormone, it's an acute phase negative reactant, which means that as inflammation goes up in the body, such as in response to metabolic endotoxemia, blood levels of 25-hydroxy-D3 go down. So it's really in response to the inflammation, whereas then usually, not always, but a lot of times the calcitriol will actually go up. And part of that might be the body might be activating the 25-hydroxy-D3 into calcitriol, because that's the bioavailable form that's going to work its magic. And when I say work its magic, I mean there's so many mechanisms that vitamin D3 modulates, whether it's actually helping to keep our tight junctions in the intestines intact. It actually regulates the tight junctions at the kissing points, so we have healthy tight junctions in our intestinal lining, as well as even regulating the expression of basically detox pumps in our blood-brain barrier, modulating the immune system and the inflammatory response, and obviously pulling more calcium out of the gut, assuming that we're eating enough calcium through our diet, but increasing the absorption of calcium from the gut into our bloodstream. But however, vitamin D3 pulling more calcium into the blood is only like half of the solution here. We then have to have adequate levels of K2, not K1, vitamin K2, which is really made by our microbiota, certain microbial species, such as Bacillus subtilis, which is one of our favorite endospore probiotics that we have in our product line. So if we don't have adequate levels of these microbes in the gut, we're not going to be able to effectively endogenously manufacture vitamin K2 from the K1 that we should be getting from our dark green leafy things. So on the Biome Effects, we actually measure the propensity for vitamin K2 production based on your microbial composition. And so that's something I look at in every Biome FX consult to make sure that they have the microbes needed to convert K1 to K2. But we can obviously supplement with vitamin K2. Particularly, we want the form MK7. There's MK4, it's synthetic, it doesn't have as long of a half-life, it's not as bioactive. We want the vitamin K2 as MK7. And this is, we own the raw ingredient. We're extremely proud of our MK7. And so it really is going to be the MK7 that works some of the magic here. So let me skip that slide because we really just discussed all of that. Now, what I want to illustrate here is the synergy between D3 and K2 to regulate the calcification or not of the vasculature. So with this, like I said before, the D3 is going to be increasing intestinal absorption of calcium, so we'll get increases in blood levels of calcium. But where do we want calcium? Obviously in our bones. K2 is really going to be the chaperone or the valet that dictates where does that calcium go. We don't want it just floating around in the blood forever because it will increase the likelihood of calcifying our arteries and our vasculature. So we have a number of enzymatic steps here. So the vitamin K2, not K1, K2, acts as a cofactor for an enzyme known as gamma-glutamyl carboxylase. Now, you don't have to memorize that, but the take home here is there's a critical enzyme that requires vitamin K2, ideally as MK7. And what this enzyme will do is carboxylate two key proteins. Now, through this carboxylation mechanism, it's actually activating these two key proteins. So the first key protein is known as osteocalcin. It's expressed by our osteoblasts in our bone cells. And its job when it's carboxylated and activated is to basically pull that calcium out of the blood and into the hydroxyapatite bone matrix. So we can have nice, strong, resilient bones. So certainly this has major implications when we think, especially our postmenopausal women. That's a whole conversation into itself. I'll spare you that tangent. But without vitamin K2, that gamma-glutamyl carboxylase is unable to activate the osteocalcin. So it's not going to be pulling the calcium into the bone. Now, there's this other protein known as matrix GLA protein, and it's primarily expressed by the smooth muscle of our vasculature, the tunica medica. So this is basically the inner layer of the arterial wall and the smooth muscle that's regulating the contractions of our arteries. And so when this matrix GLA protein is activated, thanks to the help of our K2 superhero, it's able to bind calcium and prevent it from depositing into the arteries and causing that arterial calcification that causes the stiffness. Now, I know it can get a little bit confusing with the details, but the take home here is essentially, which I think is described on this slide. So D3, that's going to pull that calcium into the blood so we have the calcium available, but K2 dictates where does it go? Is it going into our bones or is it going into our arteries and causing that arterial calcification and stiffness? So imagine this. Imagine you have a patient who is on hypertension medications, like ACE inhibitors. They might have IBS and anxiety and all sorts of symptom clusters. Maybe there's a risk of osteoporosis, risk of cardiovascular disease. They have a dysbiotic microbiome. They're missing the species to make K2. They're eating a standard American diet, not eating enough dark green leafy things. So they're not eating enough K1 or nitrate or folate or any of these nutrients. So mechanistically, they have basically impaired nitric oxide signaling in their vasculature, but increased nitric oxide activity as part of the inflammatory response being driven by the intestinal permeability and dysbiosis. And meanwhile, they're lacking the micronutrients needed to facilitate the healing pathways to recorrect all of this. And so now what I would love to show you guys is clinically, how can we really optimize this to restore the balance of what we call the gut-heart axis. Now, certainly a lot of times I'm talking about the gut-brain axis, but there's all of these gut organ axes, and I don't think the gut-heart axis is getting nearly enough attention, especially given the major ramifications of increasing cardiometabolic disease in this country. So this is what we're trying to tackle here. We want to optimize and correct the dysbiosis and endotoxemia. We want to get our short chain fatty acids and keystone species back online, because something that I should have mentioned before, perfect, I have the graphic right here. The short chain fatty acids, which we get from our keystone species like Roseburia and Faecalibacterium prausnitzii, and of course we can measure all these things on the Biome effects. Those short chain fatty acids have basically the opposite effect on the macrophages compared to the lipopolysaccharide. So whereas the LPS is going to promote that M1 pro-inflammatory cytotoxic sort of pro-disease phenotype, the short chain fatty acids, particularly butyrate, is going to switch the macrophages to more of an M2 anti-inflammatory protective and healing phenotype. So there's a lot of cool things here that we can use: total gut restoration program, megaspore biotic, immunoglobulins, our megaquin K2D3, megamarine to optimize this. And I'm going to give you guys now kind of the quick and dirty protocol on how we can very quickly start correcting this dysfunction. So if I was designing a cardiometabolic protocol for a kind of prototypical metabolic illness client, if you will, it's going to look something like this. And here's the strategy behind it. Of course, we're going to use our endospore probiotics, such as our flagship product Megaspore or HU58 or even Serene Skin. We're using those spores to increase microbial diversity, get the keystone species back online, build up the mucosal barrier, start healing the intestinal lining, and get those beneficial anti-inflammatory, immunomodulatory, short-chain fatty acids. This will help to decrease that endotoxin burden, but also, as amazing clinical pearl that I don't think enough people realize, omega-3 fatty acids, not only are they very great for brain health and metabolic health and decreasing inflammation throughout the body, but omega-3 fatty acids also decrease the translocation of lipopolysaccharide across the intestinal lumen. So that's another sort of layer of defense that we can use the Megamarine product to help support the decrease in endotoxemia. Now, a lot of you that have known me for a while, I'm a huge fan of the Mega IgG product, because these serum bovine immunoglobulins that are also featured in the Mega Mucosa can do a really great job at binding and neutralizing the lipopolysaccharide and those naughty PAMPs that are driving the inflammatory response and driving that inducible nitric oxide synthase activity, right? So we're using TGR, we're using immunoglobulins, spore biotics, omega-3 fatty acids to rebuild the microbiota, heal the intestinal lining, boost the short chain fatty acids. And then we're really using the vitamin D3K2 formulation to help support the reduction of inflammation, as well as increasing mitochondrial function. Vitamin K2, especially as MK7, which we own in our product, it can actually increase electron transport through the electron transport chain, even in the absence of CoQ10, which I think a lot of us know. A lot of our patients on statins, the statins will decrease the production of CoQ10 through the HMG-CoA reductase pathway. So vitamin K2 can help support oxidative phosphorylation and cellular energy production and mitochondrial production as well, while also decreasing NF-kappa B, which is a major transcription factor to make those cytokines. All the while, as we already discussed, the D3 and K2 are helping to neutralize that arterial calcification by making sure we direct that calcium into the bones where we want it. So it's a relatively simple protocol that can actually very quickly start moving the needle on all of these interconnected dysfunctional pathways here. So this is what I would argue to be a more functional approach to cardiometabolic health. We're going to be supporting nitric oxide production in the endothelium and not in our immune cells by decreasing the endotoxin burden to optimize vascular health and cardiometabolic function, while also improving the overall diversity of the ecosystem in our gut, increasing barrier integrity, and helping to regulate that calcium metabolism for arterial and bone health. So with that, some practical application here, I would suggest starting with the biome effects and of course your comprehensive blood work. So that way we can get a deep insight into the composition of their microbiota and what's going on with all these keystone species and short chain fatty acid production, endotoxin burden, and how that can correlate with some of the findings in your blood work. And then we can use total gut restoration, spore biotics, immunoglobulins, the mega marine fish oil, along with making sure we're obviously coaching them on how to incorporate those proper nutrient-dense foods into their diet, the increase in dietary nitrate to serve as the substrate for nitric oxide. And so this is really a nice, tight protocol that we can use with a lot of our patients and clients to optimize their cardiometabolic outcomes. So just some final thoughts and key clinical considerations, and then I think we'll have some time for some Q&A and some discussion here as well. But this is how we can very quickly start moving the needle on the gut-heart axis. So with that, I think that takes us to the end of the presentation and my rambling here. Now, before we get into Q&A, we do have some amazing upcoming education I don't want you guys to miss. So our very own Alicia Galvin and actually my dear friend Jen Maleka are doing a clinical webinar on April 9th. And then we also have another mini keynotes with Dr. Robert Silverman on May 14th. So if you scan these QR codes, that'll help you register for both of those amazing events. But with that, we'll bring it to Jenny and maybe do some discussion and Q&A here.
Thank you so much. I don't know about you guys, but I found that very enlightening. I have been just ferociously taking a bunch of notes, which I'll have to go through later. I always learn so much every time that Brendan teaches. Lots of comments, enthusiasm, and questions from our family here. So some of the first things that I'm seeing, can you speak a little bit, if you know, any relation to SIBO and cardiovascular health?
Well, certainly it depends on the type of SIBO. If it's more of a hydrogen dominant methane or then hydrogen sulfide, which I would say the hydrogen sulfide is a little bit more problematic just because it's so cytotoxic and can very quickly drive that gas and dysregulate our intestinal lining and other aspects of our health there. So yeah, I mean, the SIBO conversation, a lot of what we've been discussing with the microbiome, more so in the colon, but when we get that overgrowth of bacteria in the small intestine and getting that gas, that can very much dysregulate a lot of these same mechanisms that we're discussing. It's just a little bit higher up in the intestines. So if it was more of a SIBO type situation, I would change the approach just a little bit, where I'd probably be using the Mega IgG and the HU58 along with MegaGuard, because one of the first things I think about with SIBO is bile flow. Bile is very bacteriostatic in the top of the small intestine. So for one thing, if we decrease the lipopolysaccharide, that can alter motility. In general, that might help to some degree, but the MegaGuard is a great prokinetic. It's going to increase bile production in the liver and bile flow through the hepatobiliary complex. So that way we have optimal bile in the duodenum, so we can dissuade the overgrowth of some of those bacterial species. So of course you could use our SIBO breath test in conjunction with the Biome-FX to just further individualize that type of approach.
Certainly, thank you. I've definitely also seen studies where they show that that there's a high prevalence of SIBO in patients with cardiovascular disease and heart failure. So it's certainly something we want to keep an eye out for. So let me go into our questions here. I know you touched on this, but maybe you can review and repeat. I know there's a lot of information, and I think we can all benefit from that. Just the difference between MK4 and MK7.
Yeah, I have a a slide in another deck that goes into that very specifically. So A lot of vitamin K2 on the market's derived from soy. Most of us don't love soy in general. The MK4 is usually synthetic. It can sometimes be contaminated with other types of solvents that we don't want to be ingesting. But the MK4 doesn't have as long as of a half-life, it doesn't have the same biological effects in the tissues. So MK7 is going to be the ideal form to be supplementing with. It's actually derived from chickpeas, is where we get our vitamin K2, but MK7 is going to be the superior form for the mitochondrial benefits and the calcium homeostasis and having a much longer half-life. So then you don't have to, it would take like multiple doses of MK4 in the same day just to accomplish what one dose of MK7 could in one day. So much longer half-life and better bioavailability.
Interesting. On that same topic, we were, talking about K2's ability to shuttle calcium in the right direction. There is a question here that's very interesting. If someone does not have enough calcium and they take K2D3, the megaquin K2D3, will it cause too low of calcium in the
Hmm.
body?
That's a good question. It's hard to say because it's sort of a hypothetical generic, and of course, then it really comes down to the literal individual that we're discussing and looking at their blood work to see their calcium and phosphorus levels and vitamin D3 and K and all of these things. Because, even if they were, let's say, not taking any supplements, maybe not the best diet lifestyle in the world, and let's say they have low levels of calcium in the blood, and we don't exactly know why. Is it more of a dietary deficiency? Is it an absorption issue? There's a lot of confounding variables there. But if they were to start taking the Menaquin K2D3 product, well, now they're taking the D3 that's going to increase the absorption of more calcium from the diet, from the gut into the bloodstream. So even just by supplementing with the D3, it might raise blood levels of calcium, but then the K2 is going to be driving it more into the bone in general. So it'd be kind of impossible to predict exactly like which way the serum calcium is going to move, but mechanistically, we still want to make sure that we're optimizing the D3 and K2 levels to optimize the calcium absorption and deposition into the bone.
Wonderful. You spoke about Bacillus subtilis being one of the spores that we need to convert vitamin K1 and K2. What are some other strains that you've
You
talked
know,
about that are
I
important for this?
yeah, I kind of wish I'd included that slide because I'm trying to remember some of them off the top of my head. You might have a few others because the Bacillus subtilis stood out a lot of them like ping, I love me some HU58. I'm kind of
One of our
gapping
most
on,
popular.
yeah, what were some of the other ones? I want to say Escherichia, but I don't feel confident in that response.
Yeah. Well, I did write those down. Let me just get those here real quick for you. But before we do, just maybe you can noodle on. We do have some questions about strengthening bones in perimenopause and menopausal women and using this supplement.
Yeah, especially with the women's health focus that we have this year and our amazing new women's health probiotics that we've been discussing a lot. I mean, women's health is such a huge subject, and I was really tempted to go on some tangents in this webinar on that because especially when we think of that hormonal shift that's happening in the peri and post menopause, this has huge implications for not only osteoporosis, which tends to get a lot of press as estrogen levels drop, the risk of osteoporosis starts going up. But so too does the risk of intestinal permeability because estrogen regulates the tight junctions in the gut. Estrogen also promotes microbial diversity in the gut while promoting low diversity, which is a good thing in the vaginal microbiota. But estrogen also is a major stimulator of endothelial nitric oxide synthase. So we actually see the risk of cardiovascular disease and hypertension go up as women transition to menopause because of that large drop in estrogen that's then not stimulating the enos within the endothelium. So this also makes dietary nitrate and optimizing nitric oxide pretty important. And, even maybe potentially using hormone replacement therapy to get the estrogen also opens up a whole conversation on the estrobolome because something I've been noticing, I don't claim to be right here. It's just something I've noticed with a lot of BiomeFX reports is that I tend to see the estrobolome more robust in postmenopause. And I almost kind of theorize or wonder if that's the microbiome trying to compensate for the lack of ovarian estrogen production. So that estrobolome, I think, is really important, especially postmenopause, to make sure that we are recycling and circulating some degree of estrogen, because we need estrogen. Well, women in postmenopause still need estrogen for bone health, for intestinal health, mental health, nitric oxide and endothelial health, and just so much more. But as far as the bone strengthening component in general, obviously, D3K2 supplementation is a great quick thing to start doing. But I would say strength training is going to be, kind of far ahead the number one type of lifestyle intervention. Of course, I'm biased with that, but it's never too late to start lifting weights and strength training. It doesn't even have to be weightlifting. It can be calisthenics. It can be body weight exercises, but we have to put mechanical tension and load on our tissues to stimulate that adaptive response or specific adaptation to impose demand. So whether it's yoga or Pilates or body weight exercises, consuming that micronutrient dense whole food diet, supplementing with your spore biotics and D3K2, easy things that can very quickly start improving bone health, muscular health, and so much more.
Yeah, I know a lot of our exercise programs incorporate the friction and stress on the bones as we age. There is a great question in here that I think when it comes to the topic of nitrates, it may be one that patients will ask. What's the difference between nitrates from leafy greens versus processed meats?
Oh, yeah. That's a good question. So that is a concern some people have when they hear the word nitrate, because we've kind of been conditioned by the agricultural system, or rather the food industry, on fearing nitrate. So it's like you pick up a package of hot dogs and it's like nitrate free. It uses, celery seed instead. So really what's going on there is the risk of nitrates is the risk of developing what are called nitrosamines. So this is largely more so related to food processing with the pH, the temperature, the solvents being used, because nitrate can create what's called nitrosamines that are damaging to the body. But we can very quickly counteract this if we're eating nitrate in its whole food form with its whole food antioxidants in particular. So it's very, very different to be getting nitrates from like Oscar Mayer processed hot dogs than getting dietary nitrate from spinach with a salad and lots of antioxidants. The antioxidants like vitamin C will protect the nitrate so it doesn't form nitrosamines within the acidic stomach environment. So more so when we think of smoking, like cigarette smoke or alcohol fermentation, or the processing of deli meats like the hot dogs and the turkey and whatever. So they use celery seed as an alternative because celery seed is actually really concentrated in nitrate. So it's still acting as a preservative to avoid the nitrosamine aspect.
Um, Yes, and Ruth, just as a reminder, these QR codes that we have up here are the links to sign up for the future mini keynotes. So see some questions about that on where to sign up. Another question here, which I love, you spoke about some lifestyle factors that can help the GI microbiome, our cardiovascular health. If we are implementing a lot of these recommended usage guides, the cardiometabolic guide, and some of the things that you've talked about to promote gut health, but our patients don't comply with lifestyle changes, this is a common scenario, or maybe there's in a situation where they can't or they won't, are the benefits from these protocols still seen?
Well, yeah. I mean, it's one of those, you can't supplement your way out of poor diet and lifestyle habits, of course. I feel like I would be remiss if I didn't say that and emphasize the importance of it. Now, certainly coaching psychology is a whole conversation. How do we motivational interview somebody to essentially inspire them, empower them to take action and start modulating and modifying their lifestyle behaviors? So that's really getting into the art of coaching psychology and motivational interviewing and essentially rewiring the neurolimbic system. If our brain does not get the perceived reward in response to our effort, our brain's going to be like, why am I doing this? Why am I getting up early and going to the gym and trying to eat clean if I'm not perceiving the outcome that I desire? Which is why I love using very sensitive lab testing and biomarkers as more sensitive objective data points to encourage compliance. I try to make sure I'm doing routine testing on my clients like every 3 months because we don't want to just leave it to their perception of, I don't feel like I'm getting better. I don't feel like I'm losing weight. That's subjective. And there's a lot of self-limiting beliefs that cloud that clear image of yourself. So this is where let's use the biome effects. Let's use blood work to capture those more sensitive data points to see, even if you don't feel like you're changing, you are physiologically, and we have the data to prove it. So supplements can be a great way to jumpstart. The supplements are still going to do what they're going to do. But if we really want the full benefit, we've got to start working on the lifestyle as well, which is where working with a health coach, working with a practitioner or functional medicine doctor to really help you optimize your lifestyle behaviors.
Very well said. I love that, and I think that as practitioners, we all have that relationship to a degree with a lot of our clients and patients. I always also, if I know that that is the situation, and there's maybe a situation where I know some of these lifestyle factors are not going to be applied, I may be choosing things that are going to get them some quick relief. So if we have a lot of our GERD symptoms, and Mega Guard is going to be something really easy and low hanging, just that symptom relief can be such a motivator as well. So I often think about those types of things. Another question here. So for clients with a calcium shell on their hair tissue mineral analysis, if you're familiar with that, is there a concern with supplementing K2D3? And this, I know K2 will help move calcium back into the bone, but what about D3 exacerbating the dump of calcium into soft tissue?
That's a good question. Good to see you, Win. It's one of my FDN friends.
Wonderful.
Good to see her here. Yeah. So with that, I mean, to be fair, you could always supplement with K2 directly. We have our megaquinone product that is some K1, K2, magnesium, and zinc. So that's the megaquinone product. It doesn't have D3 in it. We also have the Serene Skin product, which has vitamin K2 as MK7, along with some spore biotics. So if for whatever reason you just really didn't want to increase the D3 that might pull in more calcium into the body or into the soft tissue. I would say though, to my take on that specific question is I think the synergy of the D3K2 combination would ameliorate that risk of a calcium shell because the whole point is we're effectively pulling the calcium in, but then depositing it where we want it to be so we don't get that calcification, whether it's our pineal gland or our arteries or whatever else. No calcification.
So next question, what about low HCl? What products do you recommend? And I know you also touched on the importance of stomach acid for nitric oxide conversion. So maybe review a little bit of that juicy information too.
Well, and certainly I welcome your tips too. I mean, I know, gosh, is it apple cider vinegar that people are really, caught up on and stuff? I've never been an apple cider vinegar guy, but looking at how do we boost the stomach acid in the gut, you could always, supplement with something like a betaine hydrochloride that's pretty standard. What are some other good? I mean, the question is, why is the stomach acid low? Like, why do they have a hypochlorhydria? Such as like if they have a H. pylori overgrowth or infection, and we might need to bust out some Pyloguard and whatnot. But usually just betaine hydrochloride would be kind of the quick and dirty way. What do you think, Jenny?
Yeah, I mean, Definitely, I love that. Although we know that sometimes there's hesitancy or maybe there's not a great response to just using straight HCl. So I'll often think about supporting with digestive enzymes, with MegaGuard, as well as thinking about that gut-brain axis. So maybe a ZenBiome dual, if that is causing some of that suppressed stomach acid production. So those are some of the things that I like to think about for low HCl. So we also have, so for clients who are eating higher amounts of animal protein to build or maintain their muscle mass, what types of products do you think are especially important in that sense? I think of digestive enzymes, first of all.
Yeah, I mean, can't go wrong with the digestive enzymes because Jenny and I and our other colleagues, we look at Biome Effects results every day basically, and we're looking at proteolytic fermentation markers on the Biome Effects. So anytime we think about protein intake, which I'm glad there's a lot more awareness. I do like the kind of rule of thumb of about 1 gram per pound of body weight, or maybe more so per pound of lean mass. I do like to keep a close eye on the blood levels of BUN, or blood urea nitrogen. That's better than a rule of thumb of like, let's look at your blood work to determine your protein needs. So I like to keep people's BUN between about 14 on the lower side, 18 around the higher side. So that's a very sensitive indicator of essentially nitrogen metabolism and protein ingestion, digestion, absorption, and metabolism. So I think the 1 gram per pound of lean mass is a good starting point, whether it's animal sources, plant sources. Now, as far as MBL products to really optimize like protein digestion and absorption, certainly the enzymes to start with, as Jenny alluded to, because if we can't effectively break down the protein with stomach acid and then the pancreatic enzymes, we're not going to be able to break it down into its constituent amino acids. But obviously, this also just brings in gut health in general with the total gut restoration of let's make sure that we optimize the microbiota status. So that way we have a healthy intestinal physiology that we're able to absorb these amino acids and then deliver them to where we need them in the body. So to me, I mean, candidly, I think spore biotics, I think the oligosaccharides in our prebiotic, I think, the immunoglobulins, such as in our mega mucosa or mega IgG, the D3K2, mega marine, to me, those are just foundational supplements that I would argue everybody can benefit from, but especially in the context of that question.
Absolutely. Couple more questions here. And just a quick pause. I know a few of you arrived a little bit later and missed some of it. This will be on the website. It will be sent out. You'll get a recording. You'll get the slides. The slides have the references. So just in case you were wondering, you didn't miss it, you'll be able to go back and review it. So just don't fret about that. Now, Brendan, I know you're a testing guy, and we've been talking a lot about cardiometabolic health. Outside of Biome Effects, are there other, heavy hitting kind of efficient labs that you might suggest?
Yeah, I mean, I think I'm a huge blood work guy because a lot of times when I'm looking at the stool test results with the Biome Effects, I want to know how is this ecosystem impacting their systemic physiology, and that's where the blood work is really going to illuminate that. So of course your basic blood work, CMP, CBC, lipid panel, iron panel, plus ferritin. But some of the other key markers, I mean, of course, we talked about the 25-hydroxy D3 and the calcitriol, if you want to look deeper into that. Of course, like your classic inflammatory marker of C-reactive protein, which CRP as an inflammatory marker, there's better markers now. An elevated CRP could be reflective of endotoxemia because endotoxemia does drive a lot of interleukin-6 that stimulates the CRP, but it's not specific to endotoxemia. But then we have serum neopterin and procalcitonin. Those are much more sensitive and specific to lipopolysaccharide burden. So if I'm really trying to gauge, like, man, I see so much proteobacteria overgrowth in their Biome Effects, and I want to see how is that driving an immune activation response systemically, I'm going to be looking at the serum neopterin and the procalcitonin. Procalcitonin is really the gold standard biomarker for sepsis, and it's very, very sensitive to endotoxemia and leaky gut. So, if you have a more dysbiotic leaky gut, you're generally going to have higher baseline levels of procalcitonin and neopterin. And then as you do like TGR and, spore biotics and immunoglobulins and polyphenols and all the good things to build that back up, you should see the CRP, neopterin, and procalcitonin start coming down. I saw somebody talking about kidney health, so I would check the cystatin C, which is going to be the gold standard there, not creatinine, EGFR, and BUN. I think those can be a little bit misleading, but cystatin C would be the gold standard biomarker to test for glomerular filtration. There's certainly plenty of others that you might want to consider, like homocysteine or troponin as a marker of cardiomyocyte damage, and so much more. But that's a good like cliff notes to get people started.
I know that there were a couple people really interested in that pearl that you shared about subclinical sepsis and nitric oxide increase. That was just fascinating to me. I think we have covered quite a bit here. We talked about kidneys. And I think, yes, I see some people are leaving here. We're going to go ahead and let you all go and enjoy the rest of your day. Brendan, any final thoughts and words that you want to leave us with? No pressure.
No, well, I'm glad this was recorded because I feel like that was a pretty dense kind of a roller coaster of science and microbiome magic. So I really do hope that you guys are going to walk away from this presentation with some good clinical pearls, testing strategies, lifestyle strategies, supplemental strategies. And certainly I hope to see you guys at some of our upcoming events in our microbiome keynotes conference in Nashville in September, so you can hang out with us in person. But thank you all so much for tuning in. This was a really great time to put this on for you all. And
Thank
Jenny,
you
you were
so
an
much for
amazing
your time,
host.
Brendan. And
Yeah,
yes,
thank
well,
you.
thanks. All right, everyone, enjoy the rest of your week, and we'll see you later.
Bye, everybody. Thanks so much.